Okay. Who can tell me something that you remember about exponents? What do you remember about exponents? It was just last chapter. Okay. What if, oh yeah.
How to deal with them through like multiplication and division.
Okay, so you're saying that if I have like x to the third times x squared, is that what you're talking about? Mm-hmm. Good, so tell me what I do there.
You would add the exponents together so you get x to the fifth.
Excellent, that's exactly right. So I'd add the exponents together and I would get x to the fifth. Perfect. Okay, and you said division also? So that would be something like x to the fourth divided by x to the third. Is that correct? Mm-hmm. So what would I do with that one?
You would subtract the fourth exponent from 3, right? And
Good.
then you would get just x.
Good. And we could also write that as x to the first. But yeah, you don't have to write the 1. Excellent. Good job. What does 3 to the fourth mean? What does that mean? What does that exponent mean? 3 times 3 times 3 times 3. Okay? 3 times 3 times 3 times 3. That's what that means. Okay? What if I had x squared raised to the third power? What does that mean?
You got to times the exponent outside, right?
Good. X to the 2 times 3, so it would be x to the... Excellent. Okay, the last one, if I had x times y and I was raising that to the third power, what does that mean? What do I have to do with that 3? It's not distributing, but it's very much like distributing, okay? So we have to give that 3 to both. Yes, and it's a lot of students think about it like we think about distribution, but it is not the distribution property. I just want to make sure that you do realize that. So we've got x to the third times y to the third. Okay? So these are all going to come up. Again, we're going to be seeing some of those from a simplifying perspective. Okay. Now, what does an A student do? What are some habits of an A student? Yes.
Comes to class.
Yes, comes to class. And I'm going to say comes to class on time. Dragging in. It's okay. It's okay. Comes to class on time. What else?
They do their homework.
They do their homework. And more specifically, they do their homework
On time.
as it's assigned. Yeah, on time is fine, but as it's assigned. Okay, as it's assigned. You work on it a little bit every day. What else? Bug your teacher. Oh yeah, I forgot about that. They didn't say that last class. Bug your teacher. Okay, and that may mean emailing. Okay, it may mean email. It may mean office hours. Could be help sessions. Okay, what else? What else does an A student do?
Study.
Okay, how do they study? How do they prepare for a test? What did I give you guys?
Practice test.
Good, practice tests. And how do you do those practice tests?
By yourself.
Good. You do the practice test by yourself. Then, depending on how you do on the practice tests, what do you do? Like if you didn't do well on a practice test, what do you do? Ask for help. You can go see a tutor. You can come see me. You can watch the videos on the practice tests. Any of those things. Okay. So those are characteristics of an A student. They're also the same characteristics of a student that passes. Okay? And I'm having these very conversations with my daughter. Okay? So, those are the things that you want to do to be successful in class. Now, we are still going to be factoring. So, factoring is not going away yet. Factoring is not going away yet. What we're going to start doing is we're going to start working with rationals. Rationals are very similar to fractions. Dr. Lytle said they're fractions on steroids. So I kind of like that analogy. So we're going to start working with rationals. Now, one of the things that's very good to do with rationals is to factor first. These are all monomials divided by monomials. And so I want us to review prime factorization. Prime factorization. Now, if you look at our very first one, if you look at 18 divided by 24, that is a relatively simple fraction that we can simplify. What number goes into 18 and 24? 6. So if I divided by 6, if I divided the top by 6 and I divided the bottom by 6, okay, I would end up with 3 over 4. Correct? Okay. And that is a completely reasonable way to do this. However, to help us prepare for what we're doing in the future, I want you to go back to factor trees. Do you remember factor trees? Okay. So when we go back to factor trees, I want us to do the prime factorization of each of these. That's what I want us to do. So I'm going to take the number 18 and I'm going to break it down. Okay? So I'm going to break 18 down to 3 times 6. Okay? 3 is a prime number. And what is a prime number? Good, it can't be factored anymore. The only things that go into a prime number are 1 and itself. 1 and itself. Okay? Now, 6 can be broken down. What can 6 be broken down to? 3. Not 3 and 3. We're multiplying. 3 and 2. Good. Okay? So, my prime factorization of 18 is 2 times 3 times 3. That's the prime factorization of 18. 2 times 3 is 6. Oh, that's not right. I said 3, right? I just wrote down 2. Yeah. Here we go. 2 times 3 times 3. That's the prime factorization of 18. Because 2 times 3 is 6. 6 times 3 is 18. Okay, now what I want to do is I want to do the prime factorization of 18. The prime factorization of 18. Or 24. It's Happy Monday. Okay, what does 24 break down to? Okay, 12 and 2. Okay, 12 breaks down to 2 and 6. And 6 breaks down to 2 and 3. So I break it down as far as I can go. So I have 2 times 2 times 2 times 3. Okay, and if you want to check it, 2 times 2 is 4, times 2 is 8, times 3 is 24. Okay, that's how that works. Now, if it's on the top and if it's on the bottom, I can mark it out. So I have a 2 on the top and a 2 on the bottom. So I'm going to cancel that out. Then I have a 3 on the top and a 3 on the bottom. So I can cancel that out. So I'm left with 3 over 2 times 2. So my final answer here is 3 over 4. Okay? Now, I realize that 18 divided by 24, you might be able to look at it and say, okay, that can be simplified, that 6 goes into both of those. The reason that I want you to think about it like we think about the factor trees and using prime factorization is when we get to problems like this right here. And that's where we're headed. So I want you to think about that, okay? Okay, let's do the next one. The next one, I have a negative in it. I have negative 36. Negative 36. The first thing that I'm going to factor out of that negative 36 is a negative 1. -1. Okay? Then I'm going to start breaking down my 36. Now, some of you might do 6 times 6. Some of you might do 9 times 4. It doesn't matter which one you do. You might do 2 times 18. Any of those are fine as long as you keep breaking it down to primes. So if a number can be broken down further, you are going to keep breaking it down. So my prime factorization for this is -1 times 3 times 3 times 2 times 2. So I write down -1 times 2 times 2 times 3 times 3. How do you check that to make sure you're right? Yeah, multiply them all together. That's exactly right. What does 63 break down to? 9 and 7. What does 9 break down to? Perfect. So I am left with 3 times 3 times 7. 3 times 3 times 7. Now, if it's on the top and it's on the bottom, they cancel. So 3 and 3 on the top, 3 and 3 on the bottom. What am I left with on top? Excellent. What am I left with on the bottom? Excellent. Okay. Now we're going to start throwing variables in there. Is that okay? Well, it doesn't matter if it's not okay. Sorry. We're doing it anyway. Okay? 15 xy. Now, you don't have to do a factor tree. I do think it's a good idea to break it down into primes. But I understand that you can look at 15 and what's the prime factorization of 15? 5 times 3. Okay? So I have 3 times 5, and then I have x times y. What is 25 factor to? Good. 5 times 5 times y. Okay? So if it's on the top and the bottom, I can cancel it out. So I am left with a 3 and an x on the top and a 5 on the bottom. So it is 3x over 5, yes. Okay. Now we're getting into a little bit more complex. They're getting a little bit more complex now. So I have -28 a squared b squared over -63 a squared b to the third. Okay? Now I'm going to go ahead and factor out a -1. And then I think 28 is 4 times 7. 4 times 7. But is 4 broken down completely? No. What should it be? Good. Now, if you need to do a factor tree, do the factor tree. Okay? Do the factor tree if you need to do the factor tree. How do I represent a times a? Never mind. How do I represent a squared? A times a. How do I represent b squared? B times b. Now, not all students will want to write down the exponents written out like that, but it's okay. It's okay if you do. It's helpful if you do. I would encourage you to do it at least to the beginning. Okay, now in the denominator, I've got -63. -63. So I have a -1, and then I've got 9 times 7. But 9 breaks down further. What is it? Good. So -63 is -1 times 3 times 3 times 7. Then I have a squared and b to the third. Okay. If it's on the top and the bottom, I can mark it out. So I'm marking out a -1. I'm marking out a 7. A times A, B times B. So I'm left with 2 times 2, 3 times 3, and a B in the denominator. you've got to be sure you write that b in the denominator. Okay, because that's where it belongs. Now, if we go back to our exponent rules, so I have b squared over b to the third. B squared over b to the third. Our exponent rules say that when we are dividing exponents, we subtract. Our exponent rules say when we are dividing exponents, we subtract. What's the difference between 2 and 3? What's the difference? 1. Okay? Do I have more on the denominator or more in the numerator? Denominator. So that's where it's going to go. Okay? You can also think about it as b to the 2 minus 3. That gives me b to the negative 1. And I know we haven't talked a lot about negative exponents, but negative exponents are reciprocals. So that's what that means. But I like to tell students just to think about where are the variables that are left over, and they're left over in the denominator. Okay. Here we go. What do you notice now? What do you notice now?
Plus sign.
The plus sign. Okay, so now we've got binomials divided by binomials and trinomials divided by binomials. So here, what I want you to do here is we are going to factor first. Factor first. Okay, so for my first one, x squared plus 4x over x squared minus 16, what is a common denominator with x squared plus 4x? I'm sorry, a common factor. What's the greatest common factor? X. Okay, so that factors to x times x plus 4. That's what that factors to right there. Okay, what does x squared minus 16 factor to?
X minus 4, x plus 4.
Excellent. That is difference of perfect squares. X minus 4, x plus 4. Okay, now what's common to both? X plus 4. Good. So I'm do x over x minus 4. Now, something that students want to do, they can't do this, but they want to do it, is they want to mark that out right there. Okay? They want to mark that out right there. You cannot do that. My final answer here is x over x minus 4. And this is a good thing to make a note of. You cannot factor part of a binomial. Or I'm going to put the word cancel here. You cannot cancel part. You cannot cancel part of a binomial. Okay? You have to cancel all of it or none of it. Okay? Okay. You cannot cancel part of a binomial. You must cancel all of it or none of it. Okay? So here I've got, look at my x plus 4 and my x plus 4. I canceled that entire binomial. I can't cancel the x in the numerator and the x in the denominator because the x in the denominator is part of this binomial x minus 4. This is a very common mistake that students make, so I want you to be careful with that right there. It's a very, very common mistake. Can I go to the next one? Okay, we get to remind ourselves how to factor. Isn't that exciting? Okay, we've got to factor this. I have 6a squared minus 7a plus 2. What's my product? Good, my product's 12. We get that by saying 6 times 2. That's how we get my product. What's my sum? -7. Okay, so my product is positive. When I have a positive product, that means I have 2 positives or 2 negatives. That's what happens when I have a positive product. 2 positives or 2 negatives. I have a positive product and a negative sum. What does that tell me about the numbers? 2 negatives. Okay? So I've got 2 negative numbers multiplied together give me 12, added together give me -7. -3 and -4. So now I split that middle term. This is what our whole chapter was on last chapter. This isn't going away. So I have 6a squared minus 3a minus 4a plus 2. I take 3a out of my first 2 terms. I'm left with 2a minus 1. I take -2 out of my second 2 terms, and I'm left with 2a minus 1. So then I have 3a minus 2 and 2a minus 1. Okay? So this factors to 3a minus 2, 2a minus 1. Okay, so I have factored the numerator. Okay, can I erase where I factored in the red? Is it okay for me to erase that? Okay. Now, the second one, or the denominator, I have 10a minus 15a squared. 10a minus 15a squared. If you aren't careful here, if you're not careful, you won't factor this one completely. So I want you to be careful. What do you notice about this one that's a little bit different than other ones? Say that again.
You don't have the end one.
Okay. It's a binomial, not a trinomial. So we don't have a constant at the end. Okay? What else do you notice? Did you say it's backwards? Tell me a little bit more about it's backwards.
Well, usually the a squared or the squared one, the highest number with the exponent goes in front.
Absolutely. That's exactly correct. That's exactly what I'm looking for. Okay? Typically, you see your highest degree written first. And if you can catch that here at the very beginning, you are going to be way happier. If you can catch that at the very beginning. Okay? And I can rewrite this as -15a squared plus 10a. And that is because this minus sign belongs to that 15, and there is a plus sign in front of the 10. That's why. That's why I rewrite that. Now, if I've got a negative in the front right here, do you think I should probably factor out a negative? Okay, so I'm going to factor out a -5a. Then, -5a times 3a gives me -15a squared. -5a times -2 gives me positive 10a. So when I do that, I'm left with -5a times 3a minus 2. And then what do I have right here? Do I have something I can cancel? Yes. So my answer to this is 2a minus 1 over -5a. Now, I want to go back to the very beginning. Okay? I want to go back to factoring right here. Because I would say many of us, if not most of us, aren't going to identify that that is backwards that early. Probably what we would identify at this point is that a 2 a 5 and an A can come out of both. That's probably what we would identify from the very beginning. So if I took a 5A out, then I would be left with 2 minus, did I erase too much of something?
You erased the 1.
Oh, okay, thank you. So then I would be left with 5A minus 3A. Now, this is typically the point where students say, well, that seems a little backwards. That's typically the point that students say that. Okay? And that's okay, because then if you don't realize it till right there, then you just go back and rewrite it at negative 15A squared plus 10A. Now, some students will get to the point where they will write 3A minus 2 over 2A minus 1, 5A times 2 minus 3A, and they may not realize it's written backwards until this point. Okay? If you get to that point, you still need to go back and rewrite this as this right here. So it's when you get that opposite or the backwards that we said earlier that you've got to factor out a negative 1. So it is possible that you're going to need to factor out a negative. Okay? So again, my final answer to this one is the 2A minus 1 over negative 5A. Okay? So, when we are simplifying, there's 2 things that I want you to remember. I want you to remember prime factorization. The other way that you can think about prime factorization is the factor tree. A lot of students remember that thinking about the factor tree. The other thing is that you are going to factor first. Anytime you jump into binomials and trinomials, you're going to want to factor. You're going to want to factor first. Okay? We are going to take this same idea and we're going to move it into multiplication and division. Okay? So we're multiplying and dividing rationals, which is very, very similar to multiplying and dividing fractions, except they are now on steroids. Okay? Can I go to the next screen? And again, we are going to remember this. Prime factorization and factoring. We are going to do that first. Prime factorization and factoring. Okay, so the first question that I have for you. When I am multiplying and dividing fractions, do I need a common denominator? No, I do not need a common denominator. No common denominator needed. Okay, no common denominator needed. Okay, so what we do here is we are still going to do prime factorization first. I think that's a good habit to get into, prime factorization. Okay, so in my numerator, I've got 2 over 4. My numerator is a 2. Is that factored completely? Can 2 break down anymore? No. What does my 4 break down to? 2 times 2. Okay, then I have another 4 in my numerator. What does that break down to? 2 times 2. Then my denominator is 5. Okay, so 2 over 2 times 2 times 2 times 2 over 5. Okay, now, if it's in the numerator and it's in the denominator, I can cancel it out. A lot of students call this cross-canceling. So I'm going to look right here first. Okay, I've got 2 and 2, and then I've got 2 and 2. So those cancel. I'm left with a 2 in the numerator and a 5 in the denominator. Now, many of you would have probably just canceled the 4s from the very beginning, and that's okay. Okay? You're thinking about that correctly if you just cancel the 4's from the very beginning. The issue is that we are about to really start using variables in this. And so you're going to want to do the prime factorization and you're going to want to factor because that's going to be more helpful. Okay, so our next one, we have 3x over 4y. The 3 times the x, it's 3 times x. What does 4 break down to? 2 times 2, and then I've got a y, so 2 times 2 times y. 8 is a bunch of 2's. How many times do I multiply 2 together to get 8?
2 times 2 times 2.
Good. 2 to the third is 8. 2 times 2 times 2. I represent y squared by saying y times y. 9x breaks down to 3 times 3 times x. If it's in the numerator and it's in the denominator, it can be canceled. 3 and 3, x and x. Okay, I've got a set of 2's in the numerator, and I have one y that can be canceled. Now, typically students do okay with the numbers. They don't remember to cancel the variables. So, I have 2y in the numerator, and I have 3 in the denominator. Can I go to the next one? Okay. Now we've got binomials. Okay? So I am going to factor first. Okay. I can't break my y down anymore, so I'm just going to leave it as y. What is x squared minus 4? Excellent. X plus 2, x minus 2. That's a difference of perfect squares. X plus 2 times x minus 2. Then x plus 2 does not factor anymore. I can write y squared as y times y. Now I want you to look and see what happens to this one. What happens here is my x plus 2 and my x plus 2 cancel, and my y cancels. So in the numerator, everything that's in the numerator has canceled. But what I have done is I have actually said y divided by y, and I've said x plus 2 divided by x plus 2. When I divide something by itself, what do I get? 1. So 1 is left in the numerator, not 0. Okay? So I have a 1 in the numerator, then I have x minus 2 times y. Now, I tell students to go ahead and leave it as y times x minus 2. If you wanted to multiply that out, you could. There's no reason to. I had another student say, does it matter what order we put it in? As long as your x minus 2 is in parentheses, it does not matter what order you put it in. So all 3 of these are correct answers. Typically, students leave it just like that. That's typically the one I see the most. Can I go to the next one? Okay. We're going to factor all of this first. Factor first. X squared minus x, that can be written as x times x minus 1. Can x plus 5 be factored? Nope. Okay. Now, for my numerator, I have x squared plus 5x plus 4. My product is 4. My sum is 5. So this one's not a difficult one. It's x plus 4 times what?
Plus 1?
Yes. 4 times 1 is 4. 4 plus 1 is 5. Okay, now I want us to look at this right here. I want to do it off to the side so that you can see exactly what's happening. The first thing that I do with x to the 4th minus x squared is I pull out my common factor. And my common factor is x squared. So then I'm left with x squared minus 1. Be careful there because x squared minus 1 is a difference of perfect squares. It factors to x plus 1 and x minus 1. Sometimes students forget that 1 is a perfect square. Okay, so now I have x times x, and I represented that x squared. That's where I got x times x. X plus 1, x minus 1. Okay, so I have x minus 1 in the numerator and x minus 1 in the denominator. X plus 1 in the numerator, x plus 1 in the denominator. Then I have an x. So I'm left with x plus 4 on the top, x plus 5, and x on the bottom. It happens. It's Monday. Okay, can I go to the next screen? Yep, okay. Now, we're going to do, this is very, very similar. Keep, change, flip. Remember that? Keep, change, flip. 7/8. I'm going to keep that as 7/8. I'm just dividing fractions. My division sign becomes what?
Multiplication.
And what do I do with my 5/6?
Flip it over to 6 or 5.
Excellent. Now, I'm still going to do my prime factorization. I still want to do that. My 7 does not do anything. My 7 stays 7. What about my 8? Can I factor it to prime factorization? Good. 2 times 2 times 2. Okay. What about 6? What does that factor to? 3 and 2. Okay. If it's in the numerator and the denominator, I can cancel it. Is that it? That's all I can cancel? I guess it is. 7 times 3 is 21. What's 2 times 2 times 5? Do we leave it like this? Yes, we leave it as 21 over 20. Good. Now we are going to use that same principle, that same idea with 16x squared y over 24xy to the third, divided by 9xy over 8x squared y squared. So we're going to keep, we're going to flip, or no, we're keeping, we're changing, we're flipping. So I keep 16x squared y over 24x y to the third. I change my division to multiplication. And then I flip this second one. So I have 8x squared y squared over 9xy. Now, students typically always cancel out the numbers correctly, but they forget to do the variables. If you will write it out, even though it seems like a long step, if you will write it out, you won't forget to do that. Okay? So I've got 2. So if I look at 16, 16 is 2 times 2 times 2 times 2. Is 2 times 2 times 2 times 2 16? Yes, it is. Then I have x times x times y. 24 is 2 times 2 times 2 times 3. And don't hesitate to do that factor tree. If you need to do that factor tree, do it. Then I have x times y to the third. Okay. X is 2 times 2 times 2. Then I have x times x and y times y. 9 is 3 times 3, and then I have x times y. If it's in the numerator and it's in the denominator, I can cancel it. So I have 2 and 2, 2 and 2. I've got another 2 here. Okay, I don't have any more 2's in the denominator. Okay. I don't have any 3's in the numerator. So my 2, so I have several 2's that are going to have to stay, and then I have 3 3's that are going to have to stay. Students almost always get the numbers correct. What they forget to do is deal with all these variables. So when they're written out like this, typically you can see them better. So I have x, and I have an x, and I have an x. Okay, I don't have any more x's in the denominator, but I can deal with some y's. I have 3 y's in the numerator that I can cancel out, and I have 3 y's in the denominator that I can cancel out. So I'm left with x times x, and then I'm left with a y in the denominator. So I have 2 times 2 times 2 times 2. 16x squared. What's 3 times 3 times 3? 27y to the first. Okay, and that is my final answer. If you write it out, if you do the prime factorization, you will be happier. Okay, I know it seems like a lot of steps, but you'll do a better job. Okay, can I go to the next screen? Can I go to the next screen? Okay, here we go. What do you think I want to do first? Yes. We are going to factor very early, but before factoring, I actually want to rewrite it. Okay? So I'm going to rewrite it as multiplication. So I have 3a squared plus 12 over 3a squared minus 15a. My division becomes multiplication. A squared minus 3a minus 10 goes to the numerator. A to the fourth minus 16 goes to the denominator. Okay? Now I'm going to factor. What comes out of the first numerator?
3.
I guess it is just a 3. Yep, it's just a 3. Three. So then I'm left with a squared plus 4. Is that difference of perfect squares right there? A squared plus 4. Is that difference of perfect squares? Okay, I've got one yes and I've got one no. Okay. What do I have to have for that to be the difference of perfect squares? A negative. It's got to be subtraction. For it to be difference of perfect squares, it's got to be a squared minus 4. Okay? Now, on the bottom, my denominator, what do I factor out?
3a.
Excellent. 3a. Then I'm left with a minus 5. Is that right? Okay. A squared minus 3a minus 10. That actually factors pretty nicely. I'm going to have a minus 5 and a plus 2. Somebody check that. Make sure I'm right. Is that what did somebody else get that? Yes. Okay, now I want to do this one right here. I have a to the fourth minus 16. That is a difference of perfect squares. A to the fourth is a perfect square. It's a squared times a squared. So then I have plus 4 and I have minus 4. Okay? But what is a squared minus 4? Yes, so I have to keep going, and sometimes students forget. So I have a plus 2 times a minus 2. So be sure you factor that completely. So I have a squared plus 4 times a plus 2 times a minus 2. Now that I've got everything nicely factored, I start marking things out. This a squared plus 4 cancels with that. So that's very exciting. Okay? I have a minus 5 and a minus 5, a plus 2 and a plus 2. Now, do you see something someone might forget? What might we forget over there on the left? The 3. Do you see I have a 3 here and I have a 3 here? What am I left with in the numerator?
1.
Yes. And then in the denominator, I have a times a minus 2. Okay?